Okay, see Lindelof videos, analytic trigonometry, verifying identities, number 21. So this is a problem that was sent to me. So this is, I guess, how I'm going to do this. Usually when I write these things, I don't use alpha. I use theta. This is kind of a pain in the ass, but I'll try to stick with it and use alpha all the way through because that's what you gave it to me. First thing I'm going to do here is remember this is almost always a left-hand proof. So I'm going to do LHP. That is to say, you can't touch the right-hand side. You can only touch the left-hand side, and you have to convert this side into that side. So this right-hand side just carries down the whole way. First thing I'm going to do is I'm going to convert these out a little bit. So secant is the same as 1 over cosine, isn't it? So 1 over cosine alpha. This negative sign is this one. And I'm not being a smart ass, but cosine alpha is cosine alpha. So I'm just going to leave it like that if you don't mind. And I'm just bringing this crap down. Can't touch it. Can't change that. So tan alpha. From here, I want to add these together because I can see this a little bit. Remember that sine is in here, right? Sine is here, but sine is also in tangent, right? Because tangent is sine over cosine. So it gives us something to think about. So here we go. So I'm going to convert this by multiplying by 1. That is to say, I'm going to multiply this by cosine alpha over cosine alpha. So we have the same denominator. So we have 1 over cosine alpha minus cosine squared alpha over cosine alpha is equal to sine alpha tan alpha. Hopefully we're doing okay here. So I'm just going to keep moving down. Remember, can't touch the right-hand side. You have to convert the left-hand side. I'm going to add these two things together. I get 1 minus cosine squared alpha over cosine alpha is equal to, same shit, stuff, sine alpha tan alpha, right? Just going to leave it like that. Bring it down again. Here's where you have to start using your trigonometric identities because here we have, look, 1 minus cosine theta. Remember this for a second. We have sine squared alpha plus cosine squared alpha equals 1, right? So if I move this around, I could say, okay, I'm just doing algebra here. Sine squared alpha is equal to 1 minus cosine squared alpha, right? So here we have this. We have 1 minus cosine squared alpha, 1 minus cosine squared alpha. So I'm going to do a trigonometric replacement, Pythagorean theorem. So I'm going to say cosine squared alpha. If your professor asks, this is a Pythag ID, right? That's why it's okay to do it. It's a Pythagorean identity. It's given. Over cosine alpha equals, same thing as before, can't touch this, so sine alpha tan alpha. But check this out for a second. So we have sine squared alpha. Well, remember, sine squared means sine alpha times sine alpha, doesn't it? Sine squared is sine alpha, over cosine alpha equals sine alpha tan alpha. Do this again. Now I'm going to break this up, right? I'm going to just pull this sine out by itself. So sine alpha over 1 times sine alpha over cosine alpha, right? Sine alpha times sine alpha gives us our cosine alpha back, doesn't it? It's equal to, look, and here's our answer, sine alpha tan alpha. If you want to look at it more, sine alpha over 1 is sine alpha. And this is a reciprocal identity, so recip ID. And sine over cosine is tan alpha equals, so it equals itself. You could actually have stopped right here. This is where you probably should have stopped and named this reciprocal identity, and that would be the foundation for your answer. Look, I hope this is helpful. This is the question just the way you presented it to me, so hopefully I addressed it correctly. Thanks for watching. If you have any questions or comments, let me know. And if you haven't subscribed, please, thanks.